Hi, welcome back. Or if you're new here, hi, I'm Axel. If you want to know why this channel exists and what it is all about, that's episode 0, linked in the I up here, I think, or here, I don't know, and below in the description box. This video delivers science news from 27th of July to the 2nd of August 2026. 9 stories covering a quantum engine that breaks its own rules, a new metal forged inside a nuclear fireball, a fossil that sat ignored for 75 years, and a stress hormone your cannabis habit might be quietly messing with, and more. So let's get into it.
Imagine a fridge that also charges your phone using the same process at the same time for free. Sounds like it breaks the rules of physics, right? In a very specific quantum sense, it kind of does. Physicists in China, Hong Kong, and Italy built a tiny quantum engine that does two things classical engines can't do together. It produces usable work and it cools something down at the same time from the same cycle. Normally, heat flows one way, hot to cold. Same reason your coffee cools down and never spontaneously heats back up. But at the quantum scale, there's a loophole. If two thermal events happen in what's called an indefinite causal order, quantum mechanics allowing them to happen in a kind of superposition of this one first and that one first simultaneously, heat can occasionally flow backwards from something cold into something hot. The team used that glitch to build a quantum version of an Otto cycle, the same basic principle behind a car engine that gets refrigeration and work output as a package deal. And they didn't just calculate it on paper, they built it using actual photons in a lab. Why care? Not because you'll own this fridge next year, but efficient thermal management is a real bottleneck for quantum computers and ultra small electronics, chips that need to stay cold to function at all. This is early, quiet groundwork toward that. Speaking of things engineered to defy the rules they're supposed to follow, material science usually forces a trade-off. Something's either strong or it bends without snapping. Rarely both. Engineers at Purdue just broke that trade-off for one particularly stubborn material. Cobalt aluminum is what's called an intermetallic. Two metals locked into a highly ordered atomic structure. That order is exactly what makes intermetallics strong, heat-resistant, useful for jet engines and gas turbines. It's also what makes them brittle. Crack them wrong and they shatter instead of bending, especially at room temperature. The Purdue team didn't change the chemistry. They redesigned the internal architecture at the nanoscale, packing in microscopic crystal defects alongside flexible, disordered interfaces that let the material absorb stress instead of snapping under it. Result, a yield strength up to 6 gigapascals, 6 to 10 times stronger than high-strength structural steel, that can still deform under pressure by 15% before failing at room temperature. For a material that used to just shatter, that's the difference between handled with extreme care and actually usable. Exactly the kind of material next-generation turbine engines need. Parts that survive extreme heat and stress without becoming a liability. That's one way to forge a new alloy. In a carefully controlled lab with a specific goal in mind, this next one was forged a very different way. Every so often, science finds something new not in a lab, but in the debris of a historical catastrophe. When the atomic bomb detonated over Hiroshima on August 6, 1945, the fireball briefly exceeded 7,000 degrees Celsius. For comparison, that's hotter than the surface of the sun, which sits at around 5,500 degrees Celsius. For a few seconds, a patch of Earth's atmosphere was hotter than a star. That fireball vaporized steel, aluminum, glass, and soil together, then cooled within seconds. And that exact combination, extreme heat, extreme pressure, extremely fast cooling, can lock atoms into structures that never form under normal conditions anywhere on Earth. Researchers examining tiny glassy droplets from the beach sands of Hiroshima Bay found one containing a completely new alloy. Iron, chromium, nickel, manganese, molybdenum, and silicon, crystallized into a highly ordered structure never documented before, structurally related to the exotic materials called quasicrystals. This isn't even the first time a nuclear blast has produced something unprecedented. A similarly unknown quasicrystal turned up years ago in debris from the Trinity test, the first ever nuclear detonation in the New Mexico desert. Different blast, different geometry, same underlying idea. Nuclear events act as uncontrolled, one-time experiments that teach materials scientists about atomic structures they could never produce or study any other way. One more thing, since we're already here, and it's worth knowing, a lot of people picture a nuclear bomb as the worst case scenario for radiation release. It's actually not. Going by the Japanese government's official estimates, the cesium-137 released by the Fukushima nuclear meltdown in 2011 was roughly 168 times the amount released by the Hiroshima bomb, and separate estimates put the total radioactive material released at Chernobyl in 1986 at around 400 times Hiroshima's. A bomb is a single instant of fission designed for blast and heat. A meltdown is a slow burning release from a reactor core holding far more radioactive material to begin with. Different kind of danger, different time scale, but by raw quantity, the accidents released more. It's fine to feel two things about this story at once. This is genuinely useful science for materials design and for nuclear forensics. And it's also a byproduct of one of the most devastating events in human history. Both are true, and neither cancels the other out. Let's move from something forged in an instant of extreme violence to something built atom by atom over millions of years of evolution inside your own eyes. Did you know that the protein in your eye that lets you see red and the one that lets you see green are almost identical? Almost. Researchers in Japan used cryo-electron microscopy, freezing molecules and imaging them in extreme detail to capture the first ever 3D structures of the red and green light-sensing proteins in a macaque monkey, whose color vision closely mirrors ours. And they found that these two proteins differ by only 3 amino acids, 3 tiny building blocks out of hundreds, yet that's enough to shift their light sensitivity by about 30 nanometers, which is the entire gap between this looks red and this looks green to your brain. That razor-thin margin explains something real: why red-green color blindness, which affects a meaningful share of men worldwide, is so common. It doesn't take much of a genetic hiccup to blur a difference that small. Beyond satisfying curiosity, understanding this at the molecular level opens the door to actually engineering treatments for color vision deficiencies down the line, rather than just describing them. Speaking of things hiding in tiny, easy-to-miss differences, our next story is about something that sat in plain sight for 75 years and nobody noticed at all. To make a real discovery, it's not enough to be searching in the right place. You have to be asking the right questions. This next story is a clean example of exactly that. In 1948, paleontologists dug up a fossil at Ghost Ranch, New Mexico, a famous site for late Triassic remains. That fossil sat at Yale's Peabody Museum for nearly 80 years. People walked past it. Some even looked at it. Nobody had properly identified it. When Yale researchers finally examined it closely, they found something new. A species that is an early relative of modern crocodiles that lived about 210 million years ago, unlike its faster, long-snouted cousin found nearby, built for speed and chasing prey. This one had a short snout, a reinforced skull, and powerful jaw muscles built for crunching bigger prey rather than running it down. The genuinely striking part: both animals appear to have died at the same moment, side by side, likely in a sudden flash flood or mudslide. A frozen snapshot of two completely different predatory strategies coexisting in the same ecosystem, right at the start of the age of reptiles. There's an old line from The Hitchhiker's Guide to the Galaxy that fits the story of this discovery almost too well. A supercomputer spends millions of years calculating the answer to life, the universe, and everything, and comes back with 42. The joke isn't that the answer is silly, it's that nobody had actually figured out the right question to ask in the first place. This fossil is basically that joke in reverse, playing out in a museum basement. The answer was sitting right there the whole time. What was missing for 75 years was someone asking the right question about it. From an old question finally asked about the distant past to a very current question, one that affects millions of people trying to avoid a fairly unpleasant appointment. Colorectal cancer is one of the most preventable cancers there is, if it's caught early. And yet, up to 60 million people in the US alone are overdue for screening, mostly because the existing options, colonoscopy prep, stool based test kits, are inconvenient, uncomfortable, or just something people keep putting off. The Food and Drug Administration in the USA just approved a second blood based screening option, Simple Screen CRC, joining an earlier blood test called SHIELD that was approved back in 2024. In a large clinical study spanning over 48,000 adults, this new test correctly identified roughly 8 out of 10 colorectal cancers and correctly cleared about 9 out of 10 people who didn't have cancer or advanced precancerous growths. Worth being precise about what this replaces and what it doesn't. It's a screening tool for adults 45 and older at average risk. A positive result still needs a follow-up colonoscopy. So this isn't a replacement for that, but just a lower friction first step that might get more people through the door in the first place. Sometimes the biggest medical breakthrough isn't a new drug. It's just removing the reason people were avoiding the tests that already existed. Speaking of things people reach for to avoid discomfort, let's talk about something a lot of people use to relax and what it might be doing to their stress system while they sleep. Cannabis is often used specifically to manage stress. This next study finds something almost paradoxical sitting right underneath that. And yes, before anyone asks, no, I did not get high before writing this segment, though at this point it might explain a few of my past editing choices. Researchers at Oregon State University measured cortisol, sometimes nicknamed the stress hormone because your body releases it in response to stress, in frequent cannabis users versus occasional or non-users. They focused specifically on the natural morning cortisol spike everyone experiences right after waking, called the cortisol awakening response. And here's where it gets interesting. That morning spike itself was roughly the same size in both groups, but frequent users started from a higher baseline, meaning they simply had more cortisol circulating in their system to begin with before the spike even happened. The researchers are careful, and so am I. This study can't tell us which direction the cause runs. It's entirely possible frequent cannabis use disrupts the body's stress regulation system over time. It's also possible people who already run a bit more stressed are more likely to use cannabis frequently in the first place. Long-term studies tracking the same people over time would be needed to actually untangle that. Either way, worth remembering that the two thoughts, this helps me relax in the moment, and this is neutral or positive for my stress system in the long run, aren't automatically the same claim. From something people voluntarily put into their bodies to something almost nobody chooses and nearly everybody now carries anyway. Microplastics have already turned up in human blood, lungs, and even the placenta. This next study starts asking the harder question: what do they actually do once they're there? Since testing this directly in pregnant people raises obvious ethical problems, researchers at VU Amsterdam built a lab model instead. 3 layers of human cells arranged to mimic the real placental barrier, plus a fourth layer representing the fetal adrenal gland, which produces hormones critical for a baby's development. They exposed this model to several common types of plastic particles. Nearly all of them crossed through the barrier layers within 72 hours. Only one type, polyamide, mostly didn't make it across. More strikingly, their presence measurably shifted hormone output. Several plastic types reduced a hormone called ethiocholanolone, and one very common type, polystyrene, found in a huge range of food containers, altered estrogen levels. The researchers are careful not to overclaim. Crossing a lab model of the placenta and shifting hormones in that model does not automatically mean real-world harm in real pregnancies, but it does mean the biological pathway for potential harm is plausible and measurable. Exactly the kind of finding that justifies the follow-up research it's already triggering. I know that's not a fun note to end on. So stay with me for one more story, because I promised myself this episode wouldn't end on that sentence. So after all that, a nuclear fireball hotter than the sun, plastic in the placenta, I think we've earned some actual good news. And this one's a good one. Every now and then, a good news ocean story actually deserves the headline. Back in the 1960s, fishing surveys off the coast of Benin in West Africa picked up hints of what looked like a deep water coral reef, but researchers at the time concluded it was almost certainly dead. Nobody followed up seriously for decades. In 2025, a team using modern sonar mapped the seafloor and spotted structures that looked like reef signatures. When they lowered underwater cameras and a remote drone about 54 meters down, far below where most recreational divers can safely go, they found a living, thriving coral garden. 8 different coral types, 8 fish species, including some genuinely great names like the Guinean angelfish and the 3-banded butterfly fish. This is what's called a mesophotic reef, a middle light reef living deeper than typical shallow water coral in conditions naturally more shielded from some of the stresses like heat spikes and direct sun that devastate shallower reefs. The researchers think this almost certainly isn't a one-off. If a reef this significant sat undocumented for 60 years, in an ocean region we don't study nearly as intensively as the more famous reef systems, there's a real chance more are still out there, simply because nobody's gone looking with the right equipment yet. 60 years presumed dead, and it turns out it was down there the whole time, quietly doing fine without us. Sometimes the science news actually ends well.
Those were our 9 science stories from that week, and honestly, a bit of a roller coaster. From quantum fridge to a fireball hotter than the sun to reef that overlived our assumptions about it. If any of these stories stuck with you, or you have something to add to it, or think I got something wrong, please share that in the comments. That's genuinely how this gets better. Take care, and until next week.